Today we're going to be solving equations of exponential and logarithmic functions. So to do that, there are a few rules that we need to follow. If a function is written in exponential form, then make sure you have your bases the same so that your exponents can be equal. If you cannot get your bases to be the same, then you must log both sides and solve accordingly. But if a function is written as a logarithmic function, you must first make sure it has the same log base on both sides of the equal sign. Then your values should be equal. If you do not have a log on both sides of the equal sign, then you have to rewrite them as exponential and solve as we always have. So let's get started. 2 to the 4x equals 32 to the x minus 1. Can I write 2 and 32 as the same base? Yes. 32 is 2 to the 5th. And I still have to raise it to the x minus 1 power. So I have 4x equals 5 times 20x minus 1. 4x equals 5x minus 5. Subtract 5x. Negative x equals negative 5. So positive x is 5. Now this one. Can I ever get 9 and 27 to be the same base? Think carefully. Base 3. 9 is 3 squared. I still have to raise that to the 2x. 27 is 3 cubed, which I must still raise to the 3x minus 2. So I have 2 times 2x equals 3 times 3x minus 2. 4x equals 9x minus 6. Subtract 9x. Negative 5x equals negative 6. And divide by negative 5. X is 6 fifths. Now I have 4 to the x equals 15. Can 4 and 15 be written as the same base? No, so I have to log both sides. Remember with logs, my exponents multiply to the front. So I have x times log 4 equals log 15. To solve for x, I divide by log 4. So, algebraically, it is log 15 divide log 4. Now you can punch your calculator. And you get approximately 1.95. For the next one, what should I do? Subtract 3. 5 to the x plus 2 equals 22. Can I ever get 5 and 22 to be the same base? No, so I have to log both sides. My exponent goes to the front. X plus 2 times log 5 equals log 22. Divide by log 5. And I still have to subtract 2. So x equals log 22 over log 5. I'll subtract 2. So make sure you punch that in your calculator carefully. I get approximately negative 0.079. to the 2x plus 5 equals 20. What do I do first? Subtract 5. Can 3 and 15 ever be written as the same base? No, so I must log both sides. My power comes to the front. 2x times log 3 equals log 15. Divide by log 3. And divide by 2. When you divide this side by 2, we put it in front of the log. So that is what it is algebraically. Since I have more than one thing happening in parentheses down here, I have to put it in parentheses. Log 15 divided by parentheses 2 times log 3. Then I need double parentheses. Then I get 1.23. All right, let's try this one. Whoops. Divide by 40. B to the 0.6x equals 6. Now we get 6 and D to be the same base. No, so I have to log both sides. And notice I natural log because I have E. What's my base here? Ln E, I have 0.6x equals natural log 6. Divide by 0.6. There's my algebra. Now I can punch ln 6 divide 0.6. And I get about 2.986. Now let's try this one. Subtract 8. 10 to the 5x plus 4 equals 27. Now we get 10 and 27 to be the same base. No, so I log both sides. Exponent goes to the front. 5x plus 4 times log 10 equals log 27. What's my base here? 10. Log 10 reduces. 5x plus 4 equals log 27. Subtract the 4 and divide by 5. So more than one thing in a parentheses, so I have to, or in the numerator, so I have to use parentheses. Log 27 minus 4, parentheses, divided by 5. And I get negative 0.514. This time I have no exponentials. So I have to check. Do I have the same log base on both sides? Log base 4, log base 4. So yes, now my values should be equal. X plus 3 should equal 8x plus 17. Subtract x. 3 equals 7x plus 17. Subtract 17. Negative 14 equals 7x. X equals negative 2. Now when I have logs, I have to be careful that my values are never negative. So if I put a negative 2 in here, negative 2 plus 3 is positive 1. So I'm okay with using a negative 2 to substitute in. Next one, do I have the same log base? Yes, I do. So 2x minus 1 should equal x plus 5. Subtract x. Add 1. And I put 6 in here. 2 times 6 is 12, minus 1 is 11. 11 is a positive number, so I am okay. Now I have just one log base. not one on each side. So then I must simply rewrite according to the definition of logs. Base to the power equals the value. 5 plus 2 equals x minus 4. 5 squared is 25. Add 4. X is 29. 29 minus 4 is 25. Positive value. I'm all right. So this next one. Base to the power equals the value. 4 squared equals x plus 3. 16 equals x plus 3. Subtract 3. 13 equals x. 13 plus 3 is 16. Positive value. I'm okay. Sometimes we have to solve problems graphically. And the reason we do is because if we try to solve them, we can't get an answer. We just keep going back and forth between exponent and log and no answer possible. So when we have to solve graphically, we put this in y1 and we put this in y2. So pull up your graphic calculators. And in y1, I'm going to type 2x plus e to the x. Enter. In y2, I'm going to type 2. Not sure what my calculator was used for last, so I'm going to do zoom 6 to have my standard window. There's 2x plus e to the x. Oh, y equals 2. There's 2. So now I have this point of intersection. So if you remember, that's in calculate above trace. Intersect, blinking on my first curve, blinking on my second curve. I'm going to make a guess. Am I solving for x or y? For x, and I get 0.3492. I'm going to see if I take a picture of this. Oh, I can't. So let's see what it was again. 0.3149. Let's try the second one. That's my y equals. I'm going to clear out what I have. In y1, I put this side. In y2, I put 1. X times e to the x plus natural log x. And 1. With my graph key. Now I can do my intersection. And on my first curve, oh, it's in the slider. On my second curve, and my guess. X equals 0.689. And then I'm going to do a little bit of life here. In Arizona, we're calling the population P, and it's been increasing at a rate of 3.5%. In 1990, Arizona's population was 3.7 million. I need you to write a formula for the model, and then find out when was the population reached 5.5 million. So this looks like an exponential since I am increasing at a rate of 3.5%. So y equals AB to the x. A, my initial amount, is 3.7 million, because it's in 1990, so year 0. So 3.7. B, a rate of 3.5 increase, so 1.035 to the x. When is population 5.5? What's my y? So I have to divide by 3.7. I get 1.486486 equals 1.035 to the x. Can I ever get 1.486486 to be 1.035? No, so I have to log both sides. And my exponent comes to the front. So x times log 1.035 equals log 1.4864. Divide by log 1.035. I get x to be about 11 years from 1990. So that would be in about 2001, the population was 5.5 million. I think you should have enough information to work on your assignment.